Okay, we are back. I have to read my code again because I didn't work on it yesterday, and instead I watched an Undertale Let's Play. But yeah, happens. Like, Undertale is a crazy good game. I rewatched. I played Undertale maybe. Well, when did it come out? I played it essentially like right after it came out, and then I didn't really do anything and stuff, and I kind of forgot about it, and now I rewatched a Let's Play. And it's really crazy how like the game is so well designed, which is like it's insane to me. Like, the creator of Undertale, Toby Fox, I don't think he had any experience like really like making any games, right, professionally. I mean, like, I stalked him, or, well, stalked. I went on Wikipedia, and like it said, he just had a few like RPG Maker games. But that's like crazy, right? I mean, like the kind of mistakes, design mistakes you find in games, like even like professional games make more mistakes than Undertale. I mean, I didn't really find any, like, design-wise, I couldn't like point to anything in Undertale that was done poorly, right? I mean, maybe they have to walk back and forth a lot, but that's like almost genre, right? I mean, RPGs just have that problem in general, almost. So yeah, anyway, so Undertale is great. So let me reread. So last time, actually, immediately before or immediately after I left and stopped the recording, I noticed that this part here is sort of wrong. So I separated the function definition for things the user can define into the function definition itself, which is this part right here. So you can have X, Y, and Z and give a implementation, and into apply, which is the function application in code. So that's the part where you call the actual function with arguments, right? I think this is still right. I'm not sure it needs to be this complicated, actually, because this part down here is the apply, right? Yes, it is. And the thing I've marked is a function. Wait, so this part corresponds to this. I can't really think about these things while I'm in talking mode, so I'll have to like program for 5 minutes, and then my brain mode switches into programming mode. But yeah, so this seems fine, actually, because this is like a function and which corresponds to exactly this part. I think that's okay. If it isn't, I will notice when I start implementing the stuff. So anyway, so that part is okay, I think. The part that isn't okay is this part where I said built-in function and built-in apply exist. So this was made to be used for plus and divide and minus and stuff. The thing is, though, you aren't, like, by definition, you aren't defining built-in functions, right? So this has to go, I believe. So maybe I'll check that again. But for example, so I could write 1 plus 2. Oh. That would be a built-in apply, and string name is plus, or the plus is the string name, and the parameter list is just what comes afterwards. And of course this also has to be changed, because that is a list of nodes anyway, so I didn't copy that over properly last time. And these are arguments and not parameter names. So I think that's correct now as far as I can see. And the thing that comes now, which is the implementation, or actually no, so first we have to write the parser, so we have to parse strings into this kind of structure right here, the abstract syntax tree, and then I can write the part that executes the Lisp function, and actually then, only then will I implement this part, right? And then I can just like make an if statement that checks the string name, and if it's like plus, it I guess it goes through all the arguments and then just sums them up. It's like arguments.sum essentially, right? And so on. And then else if for all the other types, or all the other string names. So anyway, so I think that should work. I'm gonna remove this. I'll pull it back up if I need to. And actually, I should also commit this part because I didn't really do anything commit like yet. So let me just double check here. Hopefully I don't like leak any details of my system. I think I'm fine here. Yeah, let's just, I don't know, AST. Okay. First thing I'm gonna do now is actually read up on recursive descent parsers, because I know that is a general method of implementing parsers, and I have no idea anymore how it goes. I will probably not use this actually. I will probably just implement the parser by hand essentially, so just like brute force the thing. Just because it's probably simpler actually. Recursive descent parsers are useful for general parsers, right? So if you need a program that can generate a parser for many different programming languages, you want to know about this technique. But it's not necessarily what I need to do here. But anyway, I'm gonna start reading. Yeah, so I'm a bit fuzzy on this on the grammar stuff. I'm pretty sure though Lisp is LLK, because as I understand it, LLK just means that I can decide what a piece of code does by only looking at the next case symbols. So if I'm parsing and I am, for example, at this location right here, so recursive descent parsers go through the program linearly, right? So it says so somewhere. Where does it say that? Here, basically, right? So we don't have to. I mean, it's a different formulation, but that just means we don't have to backtrack through our program, at least not infinitely many times. So the parsing essentially happens like character by character, right? And in Lisp, I'm pretty sure I can do that, because if I have I have a cursor essentially, and the cursor is my current location that I'm parsing. And then if I'm at this symbol right here, about to read fn, then I can decide which of these data types I need to represent the entire coming function definition by looking at the characters f and n, right? Because f and n, that would be a function now, right? And if it's a d, e, f, that would be a variable definition, and so on. So yeah, actually I forgot variable definition, didn't I? Man, I should have ordered these things. I would have been so much faster. But anyway, yeah, so definition is a name and a, well, I'll call it a value actually. Is that right? Define sum to mean this. Yeah, it should be correct. And actually, I mean, like, the question is, like, do you really need this, and do you really need print and read? Probably not, and also not nth, because the thing is, these are all sort of just built-in functions in a way. Well, definition isn't really, because it like spills the variable into global scope, so I should have it separate. It's more like a special case, like if. But print and read, I could just implement as built-in apply, I suppose. It doesn't really matter. I mean, I think I'll leave it for now. It doesn't matter. I can change it later pretty easily, I think. So anyway, so my language is so Lisp, or my version of Lisp, admits a recursive descent parser, so I'm good with this kind of general technique. I guess I'll like use roughly this syntax, although I don't really like the global variable here. I guess I can I pass this into functions somehow? Oh, I know how even. Okay, so I've done this before actually. This is like the general way I always implement. I mean, always. I've done it like maybe 2 or 3 times at most. But usually when I implement parsers just by hand, I would actually do pretty much this. Maybe without the separate methods, I usually had just like a sort of a context that I pass around as an argument, and then the symbol I also, or like the symbol represents where we are during parsing, right? And there you, what am I trying to say? You can either have the symbol as a global variable, or you can have it as a parameter to your functions. And then your functions, if you have it as a parameter, then like whenever you parse something, like say factor, for example, then it will just need to return the position of the parser after that function has run. It doesn't matter how it's done, I guess. I'm gonna just program and see what comes out. It really doesn't matter. So yeah. I'm gonna start using classes now. Actually, it's maybe a bit. Well, do I need it? I mean, it's so simple. Like Lisp is so small. I'm just gonna program the thing. What? Oh, I'm actually I'm in Scala world right now. Okay, here we go. Actually, it's just a wrapper. Let's do it like this. Okay, it's not a void, instead it's a node. What? Do I not have slices? Oh. Dude. Okay, apparently I need... I'm not used to the newer C++ features, actually. C# features. Yeah, and obviously that's complete bullshit. I want to write true here. Let's see. So if it's true, we just return a pool of true. Well, true. It's probably required, right? Yeah. It's false. It's false. If oh my god, it's a digit. How do I? I guess this. Look for the next space. What? Oh, it needs to be an array. Yeah. -1 if not found. All right, and I also need a. I guess I'll just call it an error. Not sure if that's the best way to represent an error in an AST actually. I'm gonna do it anyway because I'm trying to stay simple. I mean, this is not supposed to be like, oops, it's supposed to be a professional Lisp implementation. It's just for learning. Okay, so if there's no space after the number, then wait, it's more difficult than I thought actually. Well, I'm gonna start. Yeah, take the parse position. So these characters all have to be digit. That's correct. So if they are all digits, we are actually still okay. Actually, what am I doing? That's so ugly, dude. Man, like just, oops. -1. Just use a for loop instead. Sure. And actually, input from next space has to be a digit or a space. No, just a digit actually. And I mean input of I, of course. I should probably make a while loop instead. It's more intuitive. Pause. Oh, the AI auto-completed wrong. See, look, this is the problem with AI. Like it auto-completed, I didn't see it, and now I was gonna like run into a bug. Man, tough world. Yeah, anyway. So that's gonna go over all the digits. I feel like there has to be a simpler way, but I can't think while talking. I should go into programming mode actually. I won't talk anymore. Sure, hope that's right. We'll see. Wait, I'm so dumb. Wait, what am I doing? That only parses a... I mean, I thought that was correct, but that only parses an integer if it ends... If it stands at the last part of the line. I have to write an end position, right? How will I find that one though? I can't find it. It's where the integer ends, but I can't end the integer for strings. Or I mean, there's no good ending place for strings. Because I don't know beforehand. Oh, actually, yeah, it's the same thing. I just terminate. So when I find the closing quote, I should just terminate and go to the parent. And so for the case with int, it's actually like this. I also need, well, no, actually no. No, but yeah, this is fine, so I can delete the error case, I believe. Which means I could rewrite this by loop, but I'm not going to do that because I don't care. New int out of the substring that gets parsed here. Smaller in length, and it's also all characters. I think that's right. Programming live is really hard, actually. Like, I'm surprised how much slower I am, just because like I can sort of feel like in the back of my mind there's like the process running of like, what do I say, and you know, like even just like what if it's wrong, right? You don't care about these things when you're programming alone. It's just, well, if it's wrong, you fix it, right? But like making a video is very different for some reason. Yeah, so let's think through. So the parse string is the thing that accumulates. Could make this a string builder, don't wanna. It's not escaped. It starts off at this position, which is just a quote. And actually it starts off one after the quote, because we don't need the quote inside the string. If it's not escaped and we are on a double quote, we have successfully terminated the string. If it's backslash, we escape the next character and increment 1 because we don't count the backslash. Of course the backslash also doesn't have, or the backslash shouldn't be escaped. So if the backslash is not escaped, we continue. Otherwise, we simply add the thing at the current position, which might also be a backslash, or might also be an escaped quote. Then we are done escaping. I'm going to pull that inside because it's more obvious that way. And we are going to increment the counter. And then in this case, actually now if we are at the last character, so if we ran over the end of the string without finding this part, we now have a problem. So that's error, string didn't terminate, which is different from the integer case because integers don't have to terminate. Okay, now we're getting somewhere. So now this is just a new string out of the parsed string. Here we go. Oops. Okay, nice. So that covers int full string. I also need a type array, actually. I already noticed last time that I forgot that. I'm not sure actually now how Lisp even handles this stuff, because that could just be like a list. Like, we don't need arrays. Could be a list, and Lisp is dynamically typed, so a list can contain anything. And actually then I don't even need like I can just, my interpreter could just like look over the list and like check. Like if the first element of this guy is a symbol, the symbol has to be either built in, which means it has to be if, print, read, or nth, or it has to be defined by the user, or it could also be def, or it must have been defined by the user somehow, either through the, or no, only through this syntax. Is that allowed? So anyway, I can, like, do I even need all this stuff now? Like, I'm not sure. I could throw it away. Huh. Yeah, right. So Lisp parser is actually even simpler than I imagined. Because, like, this is just a list starting with a symbol. And in my version, this would be a print, which is kind of a different thing. So I'm actually like one step ahead already with this tree thingy right here. And I don't think I should be a step ahead, actually. I think it's, well, now it depends on how macros work in Lisp. Well, let's assume I want to implement Lisp, which is what I'm doing. And let's assume I have to invent macros also, which is also what I'm doing. So how would what would I want for macros? I want to be able to say, given a tree structure program, I want to be able to traverse it and insert and remove elements. Right? And the one thing I do know about Lisp is that the macro syntax is like this, approximately. So let's say I have the keyword macro, which will now apply my macro to a data structure that I pass in my really complicated recursive program, like this. And the quote says that the thing that runs Lisp shouldn't actually run this part. It should instead apply my macro to this part, and then the return value of this thing is my really complicated macro. I don't have my auto completion set up, so let's fix that. Shouldn't that be? Oh, because it's in a comment. Well, that's annoying. Oh no, I just didn't. Cyclic expand word. It's not here. Oh, hippie completion, okay. Well. Yeah, I actually don't have it defined. Let's do this. Oh wait, that's control. Control P, Control N. I do have it defined. Oh, it just, oh, this is stupid. Yeah, anyway. It still doesn't work. Oh, and now it's oh, okay. Well, that's dumb. I'm so okay. Well, I did the right thing. I just I redefined this. Yeah. Okay. Okay. I see now. That was correct before, actually. Okay. Transformed by my macro. Don't execute my really complicated program. But that is a feature of the runner, not the parser. However, the runner is called in Lisp. The parser is called the reader, actually. I know that, I think. Or at least for closure, it's called the reader. So whatever runs this code will execute the macro thing. So that's still fine with this kind of implementation, right? That's okay. Yeah, I think so. So actually I just wasted a bunch of time. I mean, not really, because I need to, like, I need to think about this stuff anyway, but I don't think I have to do it in the parser. I think the parser of a Lisp program is okay, just not caring about this. Oh, and calling read macros. What? Read macro. Dude, I hate Wikipedia just linking you to random like, where am I? What? I don't know, I guess there's a magical HTML anchor somewhere. It's actually just read this paragraph. Yeah, okay. Yeah, okay. Oh boy. List of the comma, unquote. The variable snoo has the value bar bars, then foo snoo is evaluated to foo bar as well. Foo at snoo evaluates to. Okay, so it's like string interpolation for Lisp. Okay, I see. But that's a parser thing? Like, I thought that would be part of the thing that runs the code. Like, aren't I, like, huh? Problem is I don't really know what the reader even is. Like, where does the differentiation between the parser and the thing that runs Lisp even come in? Like, why is... Like, I need a parser. Then interning. Yes, this part, which doesn't really do anything, it's just for performance, I think. Well, let's... yeah. Yeah, it doesn't matter. It's just a... Yeah, okay, so I know that. That's actually fairly obvious. But still, like, why is that a Lisp reader thing? Oh, I mean, this part is clear, but why? Like, where does the... Where does the break to compile time even occur? It's not compile time. Where does the break to execute time even come? Because this is apparently a parser feature and not a code running feature. Question is why? Couldn't I just run this code? Could run macro my macro, turn a really complicated recursive program into a other thing. Oops. Macro reads. The value of the variable names. Yeah. Let's do 5. However, most of the forms validate themselves. That's what I read before. Self-routing forms and quad parallels. That's fucking insane, but okay. Self-validating forms and quarter forms are Lisp equivalents of literals. I don't understand this sentence. Self-validating form. That's this part, right? Or this whole part is self-evaluating form. Okay, so should be constant. That returns a list 1, 2, 3. Here I define. Well, I don't understand the syntax actually. I supposedly define stuff to be the return value of should be constant. Then I set the third value of stuff, which is this one, to be bizarre. And this is quoted because it's a symbol. Then it should be constant returns 1, 2 stuff. Bizarre, I mean, yeah. Why does this have to have a list around it? Oh, because this would just like write 1, 2, 3 without list into into this part right here. It's a quoted list, maybe? I don't understand the entire thing here. Considered by style, yeah, okay. This book is beside my laptop under my on my desk right now, under a plate from dinner. I haven't read it actually. It's been lying there since like probably 4 years at least. Should probably move it somewhere. Yeah, so anyway, what is happening here? I don't understand the parser thing. So I thought, so this part is a macro. So the actual thing that I thought was a macro, I thought like Lisp macros would just let me like take a tree of stuff and take the tree and rewrite the entire thing essentially. So like take a tree as an argument and like insert elements and remove elements and stuff like that. Oh, I see now that that doesn't make sense. So actually you can still do that. It's just not even a macro at all. It's just part of how Lisp works. So of course you can take a tree data structure and define a method to rewrite that tree. That's not part of Lisp, or it's not part of being a macro. Being a macro means having the macro thing all happens with the backquote operator, right? So this is like the important thing I need to support. And that happens at reader time, which is part of the parser. So you can like define parser macros essentially. And the reader, oh, okay, now I see. So the Lisp reader is equivalent to basically the parser plus the compiler in static languages. I think that's correct now. Okay, so then my reader gets much more complicated actually, because now it has to support this kind of stuff. Values new, variables new has the variable barbas. Okay, but now how do what? Isn't that part of executing the program? Now I'm completely confused. Well, it's the foo barbas. You know what? I'm gonna ignore that, because like Lisp, like macros is just too advanced. Like right now, I don't even know Lisp, so like there's no point. Like at this point, I'm just if I implemented this, I will just like invent my own version of macros, which like would have been this strange thing which doesn't even make sense. But like even if I don't implement this now, I would just like come up with something that probably isn't Lisp. It's just something else, right? So I see now like this is a literal that's probably like interned in the parser somehow, maybe, supposedly, and it's not supposed to be modified, which is also the reason it's like undefined behavior. I mean, I can just read this, I guess. function is literally a piece of a list structure which is traversed by interpreter in executing. Yes. Oh, I did not actually know that. Okay, that explains a lot. Oh yeah, true. I did read about this Lisp code. I actually knew that. Actually, okay. Okay, so it does have a compiler. That makes much more sense. That's such a... that sentence could be like shortened by a factor of 3. Yeah, okay. Okay. I'm getting tired actually, but I think I'll continue some more. Because I didn't really get anywhere with my implementation. So the central thing that macros should allow is, in my case, implementing control structures, new control structures, because like the part here I'm not really using, like the entire like reader thing where I have a compiler in between. I'm not having I don't have a compiler, right? It's just translated to C#, so I don't need to do any optimizations. Is that true? Yeah, that's true. So even if I do the macro application step before anything else, wait, if I read my... So I'm gonna read into this data structure, and that's an AST. I then So then I could like have a separate step that takes the macros and expounds all of them, which gives me a new AST. And then comes my executor, which executes all the things that the user wants to execute. Okay, so actually the macro expansion step is probably separate. The question is whether it has to happen in conjunction with the parser or if I can truly separate the two. So I'm thinking like parser, then macro expansion, then running it. If statements that. Well, I could even compile it, which would be translate or emit C# code, but I don't want to do that because we are staying simple. I want to just run it directly, at least for now. Just execute the C# code or traverse plus if statements that run C#. And what I do not know is do parser and macro expansion have to happen jointly. I do not know. So we will see, I suppose. I don't need that anymore. Yeah, but either way, I do not really need that. Question is, do I keep it around? So the only advantage is the running part will receive my AST, which it then runs on. So therefore, if I wanna ever emit C# code for my Lisp parser, I do need this stuff, because all the other things I will have to actually implement as a function definition, which in C# would like translate approximately action and function. So therefore I should actually leave it around, because I do not know, like maybe later I want to add this part, we will see. But actually I want to leave it around, so I have the option of adding this part. Because if I leave this around, that enables me to special case, like especially array access, right? I can now do emitted code, like if I had a compiler would emit I didn't even finish that last time, apparently. That's a node, right? Because it can be anything. It just has to return an array. And that's also a node. It just has to return an int. So these are just two nodes. Is that right? Yes, because the if statement is also like this. It's very flexible. So here I would emit get array, or well, array, actually execute array, or interpret from interpret Okay, we are getting somewhere now, actually. Because if I do not do that, so the other case is I only have this like general form, which means the parser gets to see, or the parser, if I have like my array and 3, I get the third element. The parser would, in this other case, this case up here, would translate that to just a new list of that's now kind of that's sort of a symbol, I guess. So symbol, the symbol is called nth. I'm gonna use the notation without new. I'm always annoyed you have to type new, because in Scala you don't have to do that. I think it's much cleaner. Although it does, like, it can be confusing maybe for certain programmers. I mean, it can also be confusing for me, of course. I'm just saying, like, it's sort of simpler without the new. So let's say list that has this symbol nth, and also the symbol. Isn't a symbol? No, it's now a variable. Actually, it's my array that has to be evaluated. That's of type node, and also 3, which is also of type node, because the parser can't do more than that. Actually, that's not true. It could infer that as a literal int. So we got that part. So it's just a very general list. And now this translates, compiler translate into interpret list. This. So that's actually the entire emitted code. So the emitted code is this. And now my definition for interpret is basically just whatever. It's like an S expression, actually. So that's S expression, which is, I mean, it's a node. I call it node in my but the Lisp calls it S expression. So here I have the expression. Well, here I just have the special case. So if expr dot, actually that's a list. It's a list. It's a list node. This part up here, right? So if dot nodes is 0, if that is nth, then I do something. Then I implement the special case, which is this one. So then I interpret the array, which is the first or the second argument, and I access it at element nodes of 2. Okay, yeah, here we go. So that should be, oh, I forgot the thing here. Wait, what? Oh, I don't need that, yeah. Okay, anyway. That's not a void, of course. That's a general, like a general Lisp value, maybe a node or something. Doesn't matter. Okay, so here yeah, but that just runs. So that's an interpreter, and here I actually. Is it that much of a difference, actually? So this implementation is here either way. It's just that Dude, I'm so confused. Dude, the problem about Lisp is it's just like compile time and parse time and runtime. It's kind of all the same. Like that's literally the point of Lisp. But as a result, I'm so confused. I need to think of it as a spectrum, I think. It's just like it's not even like I can just I can do whatever I want. I think is the solution. Because just now I was thinking, like, if the node, like if the user writes this, right, in the first case, if I had a compiler, I could emit actually interpret my array and then just pass 3, like a literal 3 into this, right? That would be my emitted C# code. So, and then I run that, right? I run the C# program, I mean, and then that implicitly runs the Lisp program, because interpret is also part of the C# program I actually need to run the Lisp program at all. So what? If I had my array, which is an array that I previously defined in my Lisp program, a compiler step could actually come ahead, or come and say that my array is a array, like if it understood these kind of, I mean, I don't really have even arrays at the moment because I forgot them actually. but let's assume I write arrays maybe like this. 4. Then that compiles to just straight up this, right? And now if I want to have a compiler, then I could like say, well, can I say that? Here's where it gets confusing, because my array has to be like known to the compiler. It can't just, like, if this like is undefined, it wouldn't, like, what would it do? Because I'm pretty sure the parser can't actually check. Like macros are Turing complete. So the parser step, which runs first, it can't actually check that my array has been defined, because a macro, which comes later, could modify the input, like the Lisp source code, and define my array somewhere else where it doesn't see it. And only then comes a compiler. So even if like these two steps were like, even if they happened at the same time as I've written here, no, that's not true actually. No, that's not true. Then the compiler could know. I don't know why, because I don't understand macros. No, it makes sense. Yeah, so macros can like generate any Lisp program, and if they run at the same time as the parser, actually, then it's as if the user had written the Lisp program. So the macro doesn't even like enter into the equation. It's just if I execute macros, this part will be a Lisp program, and the compiler can compile it. And as part of compiling it, it can emit this kind of code. Yeah, okay, that makes sense. Yeah, okay, I see now. That makes a lot of sense actually. Because now this is just a scoped variable, like it defines the variable somewhere and it can run it, or it can refer to it in scope. Okay, so I think I understand now. So I decided, so as I said, I'm not going to do the compile step right now actually, but it still makes sense to split this up, because a compiler would be able to generate more efficient code now, I think. And I will see if what I just said is correct as soon as I get to the compiler, if I ever get to the compiler, but we will see. But I think that should be right, because I get to emit these kinds of expressions, these kind of sort of literal definitions, which in turn, like the C# compiler can then also optimize, right? Because I'm like, the C# is sort of a weird in-between thing, right? Because C# itself is unfortunately statically typed, which Lisp isn't. So maybe actually I can't even, like this, like doesn't work. I mean, it has to be an arrayless, definitely, right? Because Lisp can come ahead and modify it, but maybe it actually doesn't work at all, which I don't know yet. Okay, yeah, but anyway, so that's okay. This is all fine. So therefore, I am going with this approach here, deleting this, because I might want to emit more efficient C# code, if it's possible at all, which I don't know. But it might be possible. This was my example of how I would write it inefficiently, which I do not want anymore. Oops. Yeah. That's what I wrote last time. Get a function name instead of a function value. Not really, because they are splice expressions. And I'm gonna the thing is, I don't need to do that, because right now what I'm actually doing, in a way I'm programming my own Lisp virtual machine. So essentially, like, I mean, when I get to executing this, I will just execute it in C#, right? It's not Lisp, like my implementation doesn't compile to C#. I will literally just execute C#, right? So maybe actually the C# code that I talk about emitting here, maybe I will never actually do that. And I will instead efficient byte code, whatever that is then, right? It could also mean that I do like certain kinds of optimizations and ignore the rest. Yeah. Because C# isn't ideal either, right? C# is statically typed, and it's very annoying to have like a static foundation underneath a dynamic language, which Lisp is. It's like the inverse. Like Python right now is implementing static types for its type system. Like that's optional, right? But like this case is like the reverse case, which is it's very, very annoying. Like I program with TensorFlow. TensorFlow is statically typed and Python is dynamically typed, right? And it's so annoying because TensorFlow is underneath and like Python lets you write code and TensorFlow doesn't accept that code. It's horrible. It gets horrible to debug and write code and stuff. Yeah. Yeah. So anyway, so that takes care of this. So this part is implemented. I can do digits. I can do strings. And the next part, which is actually the hard part now, is I need to implement the S expressions. So the S expressions are all the stuff that comes in parentheses. So if the input parse is S, then I'm like in special case land. Parse all the built-in functions. Translate to my native ST nodes and allow me to later optimizations. And one branch that is entirely to do macro handling. That's entirely unclear. This part I think will just be an error. Non-character. Say which character it is. It is the character. Wait. It is the character input. Parse plus. Oh, it's just because this part doesn't return anything yet. Right, so if gonna use substring here because I'm gonna make sure actually, you know what, I'm gonna take a break. I'm probably gonna upload the next part as the next video, but I'm gonna keep recording today, so you probably like won't notice. But I'm gonna like eat something. I haven't eaten really anything yet. Then I'm gonna continue here.